Okay, well, welcome back to school, everybody. My name is Miles Chen. I'll be your teacher this quarter, and for Stats 10, the greatest class ever. I'm really excited because I love statistics, and I look forward to teaching this class. Let's see. Yeah, so when I took intro stats as an undergraduate student, I did not attend UCLA as an undergrad, by the way. I wish I did, but when I took intro stats as an undergrad, it changed my life. I was an engineering major. I finished my engineering degree, but I fell in love with the subject of statistics, and so after working a couple of years, I decided to come back to grad school. I came here to UCLA, and I got my PhD in statistics, and now I have my dream job of teaching statistics to you guys. I'm not kidding. This is my dream job because I love statistics. I love teaching, and so I'm excited to be here. I'm excited to come to work every day, and I'm excited to have you guys as students. You guys are, like, I don't know any of you yet, but I'm confident that because you are here at UCLA, you guys will be excellent and the best students. So let's see. I think CCLE is broken right now. Yeah, it still is, right? Okay. So I was going to try to get the syllabus posted online, but I couldn't. So I guess I'll show the syllabus up here, but it'll be brief. Where did I put it? Oh, Stats 10. Okay. Here it is. Okay. All right, so this is me. I teach, this quarter I have 2 Stats 10 sections or lectures, so please make sure you include which section you're in so I can look you up. Anyway, okay. And my office hours are, well, they will be posted on CCLE. But it'll be Mondays from 3 to 4 and Wednesdays from 11 to noon, okay? But you guys can check online. This is how your grade's going to be determined. We're going to have 4 quizzes, each of them worth 4%, so a total of 16% for your quizzes. 15% midterm 1, 15%, midterm 2. 30% final exam. You'll have 4 lab assignments, 4% each, okay, for a total of 16%. 5% homework and 5% iClicker participation. So you guys have to get a clicker, and we'll use that, okay? We'll start using the clicker in 3rd week, so you guys have a couple weeks to get one. So if you want to order one used or something, that should give you enough time for it to arrive in the mail. You can get it used, and then you can just, all you have to do is register it on CCLE, so it associates the clicker remote with your student ID, and then you'll get credit for it, okay? This is the textbook that we use. You don't have to get it new. You don't need the fancy, whatever, MyStatLab stuff or any of that stuff, okay? You just need the text, okay? Some of you guys have asked, is the 1st edition okay? All right, as far as content in the textbook, the 1st edition I would say is okay, but the problem is for the homework problems, the numbers will not line up, okay? And so when you try to do the homework and you go online and you're looking up the problems, it's going to be different problems. So if you get the 1st edition, try to find a classmate with the 2nd edition and see if they'll give you, you can get copies. I'm not supposed to encourage copies of stuff, but maybe you guys can share homework stuff there, okay? As far as homework goes, I'm going to assign homework problems online, but I'm not going to collect homework, okay? So I'm going to just trust that you guys are doing your homework, and really the homework is for you guys, okay? It's for you to learn the material and kind of reinforce, make sure you understand the stuff you've learned in class so that when it comes to quizzes and tests, you're ready, okay? If you feel like you've got a better use of your time in your life, no one's going to be checking to see if that's the case, okay? Nobody complained about it last quarter. At the end of this quarter, I'm going to give everybody 100% for their homework grade because I trust you guys, and that's that, okay? So as far as homework goes, please do it. I think, I will also post all of the answers to the homework online as well, so after you've done it, you can check your answers and make sure you're doing it correctly and make sure you understand stuff. And then, if you see that you're getting the wrong answer, you keep making the same kind of mistake, then you know something's wrong, and you can come visit me during office hours to get things sorted out. But if you don't do the homework, you're not going to make these discoveries until you take the test, and then you get a bad grade, and you're like, oh, maybe I didn't understand. But anyway, that's that. Okay, you need a calculator. You're not allowed to use your cell phone as a calculator, so you need to get some kind of calculator. I highly recommend getting at least a scientific calculator. This is the one I use. Here, let me put this up. It looks like this. This is the Casio FX115 MS, or the ES you can get for like $15 on Amazon. I promise you it will make your life a lot easier over using just a 4-function calculator. Now, many of you have taken like calculus or whatever, and you have a TI, a billion, whatever, and it does all sorts of fancy stuff. That's fine. You don't need to spend an extra $15 so you can get a dumber version of the calculator. But there you have it. Okay. And then we have, okay, and this is kind of a list of all the topics we're going to cover and blah, blah, blah. Okay, this is just so, like, if you're applying to a grad school and they want to say, like, did you get a proper statistics education or something, and you have to say, well, this is all the stuff I learned, it's there, okay? Or this is the stuff you're supposed to learn in this class. But anyway, okay. I've created also a frequently asked questions document, and this will also be posted online, okay? And so stuff like, I'm enrolled in this section, can I attend the other section, okay? As far as lab goes, you have to go to your section, okay, because there's a limited number of seats in the lab, and so I can't add students because we're going to run out of seats, okay? So so that's that. If you're waitlisted, you just have to wait for someone to drop, okay? I can't add you, I can't give out PTEs because of the lab seating situation. And all these other questions about, how does this clicker stuff work? I'm going to miss class on this day, or I got sick and I missed class and I missed the test, or whatever. These should answer all of your questions. So, when it gets posted online, please take a couple minutes to read through it, okay? Okay. If you'll indulge me, I'd like to just say just a few personal things. Not too personal, but it's spring quarter. I hope every one of you has a great spring quarter and gets through everything fine. But with a class size this big, chances are one or two of you might endure some kind of hardship or struggle, and life might feel overwhelming or something like that, okay? And so if that happens to you, I just want you to know that you are not alone in facing your struggle. There are people that care about you. There are resources on campus that you can turn to. No grade in any class is worth sacrificing your physical health, your mental health, or your integrity for, okay? There might be a temptation to be dishonest or something in order to cope with something that you're struggling with. But wherever you are headed in life, you want to be proud of the journey that you took to get there. So I want to encourage you to, seek help or whatever if that happens to you, and make it through. Chances are 99% of you, the rest of you, will not have to endure anything like that. And so if you notice someone struggling or in pain, I encourage you to be a support and help to to the rest of us who can use help. So that's my encouragement to you. I hope no one has to suffer anything, but I just wanted to say that. Okay, anyway, I really hope we're going to have a great quarter. I think we will. So with that, we'll get started. Well, I guess, are there any questions before we get started? Yes?
So we don't need a graphing calculator?
You don't need a graphing calculator, no. Okay, if you have one, great. If you don't have one, you don't need one. Okay? Yes, another question.
Where are your office hours?
Where are my office hours? I'm going to have them in the Math Sciences Building, room 8141, okay? That's like called the Statistics Tutoring Center or something. There is a statistics club that you guys might want to join. And the students there often offer free tutoring services throughout the quarter if you need help, and I will have my office hours there as well. I do have my own office, but that's I generally don't hold office hours there. Okay, but that's that. Okay. Another question, yes.
Do we need lab manuals or just?
You do not need the lab manuals. Okay, I'm only going to have 4 labs this quarter, and I'm just going to post the PDFs online. Okay, so you have that. Okay, are we good? Yes. Okay. All right. Statistics. Let's go. I'm really excited. I'm like I got the jitters because I'm so excited here. Can you guys see that okay? Yes, all right. Statistics, yes, all right. This is my love. Okay. All right, so let's start off with the important question. Well, why do I love statistics? Or, why do we bother studying statistics? Why? And I argue that we study statistics to gain a better understanding of the world around us, okay? And in particular, statistics allows us to make conclusions from limited data. Okay, let's see. This is Stats 10, Lecture 4. Okay, so I am recording my screen, and assuming nothing breaks down, I'll post this on YouTube with links on CCLE, and I'm also saving my lecture slides, and I'll post those online as well. Okay. So some of you guys, everyone has different learning styles. Some of you guys learn better if you take notes in class. Others of you learn better if you sit back and just pay attention. So whatever you want to do, that's up to you, okay? Okay, so in particular, statistics allows us to make conclusions from limited data. Okay, so what do I mean by that? Well, let's say, we might start off, we usually start off with some kind of research question. Those of you in the back, you can see everything on the screen good? Give me a head nod. No, you can't. Make it bigger. I don't know how. I'm sorry. Maybe. So if you know, I would encourage you to come sit closer to the front, okay? And there's plenty of seats. Question? Yes.
Is it possible to use a wider brush or a wider pen?
A wider pen. Yes, that is possible. Maybe that's a good one. I don't know. Okay. All right. So we'll usually start with some kind of research question. All right. So let's say, for example, is that better? I don't know. Yes? No? Now it's too much? It's 0% better? I blame this projector. Max? Okay, let's try this. Okay, so for example, let's say our question is, you know, oh my gosh, this is like hurting my own eyes. Does an experimental medication, it looks absolutely ridiculous on my screen. Help fight cancer. Better? Okay, better for you guys. I guess that's all that matters. I mean, you guys are the paying customers, all right? So it's my job. Well, I have two people that are really ultimately responsible, right? I have to report to the university. I have to evaluate whether or not you guys can do statistics. So that's my primary responsibility of basically giving you guys grades, okay? But my other job is to make sure you guys are being educated and feel like you are being educated. So, or feel like you're receiving a good education. So, if anything, if you're not pleased with anything in the quarter, during the quarter, let me know, okay? I want to make sure I get top marks for the student evaluations. They're very important, especially because this is my first year as a lecturer here at UCLA, so your student evaluations are very, very important as far as the future of my career. And okay, I'm serious, and so I think I do a good job. But if you feel like something needs to be improved or changed, please let me know during the quarter so I can make those changes, and not at the end and take it out in the student reviews. Okay, so anyway. That's where we are. Okay, so we have, does an experimental medication help fight cancer? Okay, now to answer this question, we have to think of the relevant population. Okay, and let me actually, this is a little bit too vague, so let me just say, like, does an experimental medication help fight, let's say, lung cancer? Okay. All right, so to answer this question, we have to think of the relevant population. And so the population is everyone relevant to the question. Okay, and so in this context, the population would be is everyone with lung cancer. Okay, now this population, any population, generally, is almost always too large to be studied directly, okay? So populations, so when we think of everyone relevant to answering our question, populations are almost always too large to be studied directly. Okay, it's almost, in order to see if the experimental medication helps fight lung cancer, that's just too many people to try to administer an experimental medication to and study. It's too many people, and probably not even ethically possible to do an experiment on every single person who has lung cancer. But that would be the population. We want to know if this population, if this medication would work on the population at large. Okay, so populations are almost always too large to be studied directly. If we choose to study the population directly, that's called a census, by the way. Okay, so studies on the population itself is called a census, and we rarely conduct censuses in real life. I mean, we have the population census once every 10 years, and then we also have another kind of a census once every 4 years in the form of an election. Okay, and and in those cases we can only ask simple questions, kind of like, are you a person in the United States? That's for the population census, and we get a count. And as far as elections go, it's which candidate do you prefer to be president or whatever it is, okay? And you're trying to get, every single person who is able to vote that way, or willing to vote, I should say. And so, but those types of things are quite expensive, and so we rarely do those. I'm going to flip to the next slide. Okay. And so because populations are too big, we will take a sample and study the sample. Okay, and so kind of to illustrate this, I'm going to draw a big circle here, or a big ellipse. This is the population. I'm going to say this thing is too big. And so what we do instead is we just take a little piece out of this population, okay? Okay, and this piece, we select it. We have our sample, okay? And we study the sample. This is an eye. That's what it's supposed to be. Okay. And then based on what we see in the sample, we make conclusions about the population, okay? This process is called statistical inference. Okay, and this is the idea of making conclusions from limited data. So I'll just draw a dotted line. say that is inference there. Okay. All right, and so as far as inference goes, if we want our conclusions that we're making based on our sample to be valid about the population, our sample must be representative of the population. Okay. Okay. All right. So everyone can read this okay now? It's a little better? Maybe? All right. Okay. Samples that are not representative are called biased samples. Okay. So, you know, if we were to ask you guys, who will you vote for in the presidential election, the results that we get from that survey will really tell us nothing about the general population, okay? Because you guys are not representative of really any group, okay? You're not representative of the United States. You're not representative of California or Los Angeles. I mean, we might be able to argue that you're representative of UCLA undergraduates, but that's probably not even quite true because chances are you're taking this because it's a GE requirement for your major or whatever it is, and so students of different majors probably aren't even wouldn't even think of taking this class, and so you know, at best we can say you're representative of other Stats 10 students, which really is probably not going to tell us a whole lot about anything in general. So, you know, and likewise, if we conducted a survey in Texas or something, the results we get there will not be representative of the United States as a whole either. Okay, so if we want to know, you know, who's going to win the election come November, you know, it's quite a tricky thing to do because you have to think, how are we going to get a representative population? And what's likely is that even if we were able to get some kind of representative population today, that population might not be representative of the United States in November, okay? So who knows, all right? So it's hard. It's hard to get representative samples, okay? That's worth writing, okay? It's difficult to get a... What is this thing that keeps popping up? Okay, it's difficult to get a representative sample. One method that should Something is crackling. One method that should give us a representative sample, that should, but is not guaranteed to do so. Is simple random sampling. Okay, let me abbreviate it. Okay, and so with the way simple random sampling works, SRS begins with a sampling frame. Okay, so the sampling frame ideally is a list of every single person in the population. Okay. By the way, if I flip a slide to the next thing and you didn't get it down or you need me to slow down, just let me know, okay? So ideally, the sampling frame is a list of every single person in the population. This is actually very difficult to do, okay? So let's say I wanted you to get a sample, a random sample of people living in Los Angeles, in the city of Los Angeles, okay? What could we possibly use as a sampling frame? What could possibly be a list of every single person in LA? Yeah. Phone book. Okay, so we often think of the phone book, but are any of you listed in the City of Los Angeles phone book? Probably many of you are not, okay? Which means that if we were to use the phone book as a sampling frame, there is no chance that many of you will be selected, okay? Because you aren't part of the sampling frame. So any deficiencies that exist in the sampling frame will be deficiencies that you have in your random samples. Maybe we say, okay, well, we don't have a phone book, so maybe we can go on Facebook and see who's geolocated in Los Angeles. Okay, but a lot of people don't have Facebook, all right? I have no idea. You know, there's census data that was gathered about 6 or 7 years ago. That's going to be outdated. Many of you have moved here recently, within the last 6 or 7 years, and so you will certainly not be in the in that thing. And people have moved out, so that data is old. And so trying to get a proper sampling frame for just something simple like the city of Los Angeles is very difficult to do. Okay, so this is very difficult in real life. Okay, now many of our statistical methods assume that the sample we have is a simple random sample. Okay, and so we're gonna when we work through problems, somewhere in the problem it will say something like a sample was randomly selected. Okay, in those just few words, you have to imagine a very difficult process of getting a random sample that's truly random. Now, there are major organizations like Pew Research and Gallup that have spent a lot of time trying to figure out how to get representative samples. So, anytime you see stuff on the news that says so-and-so's approval rating is this, or so many people, this percentage of people like blah, blah, or whatever, that's because they've tried their best to get a representative sample, but no sampling method is perfect. As far as the intro class goes, we're just going to say, hey, we got a simple random sample somehow. But it's kind of a hard thing to do, okay? So ideally, the sampling frame is a list of every single person in the population, and then what we do is just we select people from the sampling frame at random, one by one. Okay? At random means truly at random. It's not closing your eyes and just saying this person and this person, because that's not random. All right? It would be something like you take their names and you put them on slips of paper and you put it in a hat and you shake it up. Or you assign every single person a number, and then you get a random number generator, and you use those to pick people, okay? Kind of closing your eyes and saying this person and this person is not really random, because our process of dropping our finger down is controlled by our brain, which is very bad at randomness, okay? So we select people from the sampling frame at random one by one, and what this does is this makes every single person in our sampling frame has equal chance of being selected. And every single possible sample equal chance of being selected. So what I mean by every single possible sample is if you think of lotto numbers, okay, the lotto combination, 7, 15, 23, 31, 45, has the same probability as 8, 28, 29, 42, whatever, okay? Has the same probability as 1, 2, 3, 4, 5, 6, or whatever, okay? Every single possible combination of lotto numbers has an equal chance of being selected. It's very unlikely that the lotto numbers are 1, 2, 3, 4, 5, 6, but it's equally unlikely that it's exactly 7, 15, 28, 32, 45, or whatever, however, assuming I said the same number of numbers, okay? But this is a simple random sampling. It should give us a representative sample, but it's not guaranteed to do so. Okay, let's see. All right, and so let me just kind of give you a quick overview of where we're headed in the course, okay? So we're going to start off with descriptive statistics. Okay, descriptive statistics is summarizing data with just a few summary values. Okay, so basically, we take data, lots of it, and summarize it with just a few values, okay? And so we'll talk about certain aspects of the data that we want to be sure we're summarizing, okay? So, if you had to describe a person, it's hard to do, okay? But you might be able to give you some essential information about the person. You just say, oh, this person, I don't know, yeah, I don't know how you describe a person, but as far as descriptive statistics, we're trying to take lots of data and we're just trying to summarize it with just a few values, okay? And we're going to spend the first few weeks talking about that, okay? And then after we do descriptive statistics, we're going to do something different, and that's going to be probability. Okay, and probability tells us how likely or unlikely certain events are. Okay, and based on our understanding of probability, we'll talk about probability distributions. Okay, and so these assume that certain outcomes will follow certain patterns. And after probability distributions, we talk about sampling distributions. Okay, and so sampling distributions talks about the probability of getting certain summary values. Okay, this is the probability of getting particular okay. And so once we understand the probability behind getting these summary values, we can go back to our understanding of descriptive statistics, which is about getting those summary values, and combine it with our understanding of the probability of those summary values, and this comes together for statistical inference. Okay, so statistical inference is taking our understanding of summary values and their probabilities to answer questions about the population. Okay, so we take our understanding of summary values and their probabilities to answer questions about the population. Okay. So descriptive statistics, we're going to spend the first few weeks. This is going to take us to, I'd say, midterm 1. Okay. Probability distributions, all of this stuff, this will take us to midterm 2. And then everything we do about statistical inference, this will get us through our final exam. So this is kind of a very broad overview of where we're headed in the course. I'm looking forward to a great quarter with you guys. I hope you guys enjoy statistics. Maybe you'll fall in love with it as well. All right, you guys have section tomorrow. And I will see you guys again on Wednesday. Have a good night.